Good morning, students. Dear students, today we are going to start a new chapter, that is chapter number 4, motion in a plane. Yes, students, in the previous chapter, that is motion in a straight line, motion in a straight line. In the previous chapter, that is motion in a straight line, we had discussed about a body traveling in a straight line. Whatever the examples, whatever the derivations, whatever the concept we had discussed it for moving body in a straight line, and if we are considering about the moving body in a straight line, means one dimension is needed, means either of the axes, that is either x-axis or y-axis or z-axis, any of these three axes is sufficient for describing the motion in a straight line. But now we are talking about motion in a plane, and as this is motion in a plane, it means to say that we have to discuss the moving object in 2D, and if we are talking about 2D, two-dimensional motion, means in three coordinate axes, that is x, y and z. In these three coordinate axes, either we have to select two axes, either we have to select xy or yz or z or x and z. Any two coordinate axes we have to discuss. So here it is important for us to know about the direction. It is important here to know about the direction of motion. To clarify it, I want to take you an example. Suppose an object is moving in a straight line. You all are knowing that this body is moving in this direction, and that direction is clear to the observer about the object. But if I am saying that an object is moving in this plane, so suppose the object is moving in this direction. Now, how can you define the direction of this object? Because to describe the direction, you have to need the coordinate axis. In which coordinates axis you will take this moving object? So it is important here to know the resolution part of this moving object. Means this moving object can be resolved into two different directions, and simultaneously we will take both the resolved components to know about this vector. So direction is important here. So knowledge of direction is important here. So before studying the motion in a plane, we have the first objective to know about vectors. What are vectors? So first topic of discussion in the motion in plane is about the vectors. First we will discuss about vectors. In this we will discuss about properties of vectors, properties of vectors, then addition of vectors, addition of vectors, subtraction and multiplication, subtraction and multiplication, multiplication of subtraction and multiplication of vectors, then resolution, resolution of vectors, resolution of vectors. These topics we will discuss in vectors. After that, we will, by the help of these vectors, we will try to understand some applications of motion in a plane, just like in projectile motion. In projectile motion, this is the second part. This is the second topic. First topic is vectors, second topic is projectile motion, then about circular motion. Then we will study about circular motion. So this is the brief description about this chapter, and we will discuss each and every topic one by one, and I think 10 to 12 lectures are required to complete this lecture, to complete this topic, that is this chapter, that is motion in a plane. So first of all, we are going to start about vectors. What are vectors? So dear students, we have to discuss here about vectors. So in this chapter we will discuss about basics of vector analysis. Basics of vector analysis we will discuss, and its application in physics, and its applications in some basics of vector analysis and its application in physics. Now, which physical quantities are called vectors? Which physical quantities are called vectors? Vectors are those physical quantities which have, apart from the magnitude, apart from the numerical value, apart from the unit, there is a direction mentioned. There is a direction mentioned. Means if a physical quantity, in addition to magnitude, in addition to means a part of magnitude, it has a specified it has a specified direction. Second one is obeys parallelogram law of vector addition. We will discuss it later. Obeys parallelogram law of vector. Obeys parallelogram law of vector addition. And third is its addition is commutative. Its addition is commutative. Third one is its addition is commutative. that is vector A plus vector B is equal to vector B plus vector A. Means, suppose I am saying that a body is moving 3 meter, but we had not specified the direction, so it is a scalar. But if we had stated a 3 meter towards east, 3 meter towards east, then a direction is specified along with the magnitude, so it is a vector. It obeys parallelogram law of vector addition. Parallelogram law of vector addition means to say that I am writing just formula, and the later on we will derive this. Parallelogram law of vector addition is equal to R is equal to A square plus B square plus 2AB 1 by 2 cos theta, 2AB cos theta 1 by 2. Means the addition of vectors should be done. Means if A and B are two in physical quantities, then the magnitudes of these physical quantities can be added on the basis of this formula to get the resultant of these two physical quantities. And commutative means if the position of A and B is interchanged, both the results are equal. So if these three conditions are satisfied by two physical quantities, then these two physical quantities are said to be vector, or that quantity is said to be vector. And if any of this condition is not satisfied, if any of the above three conditions are not satisfied, then that physical quantity is not a vector. Quantity. Means any physical quantity should be a vector if it must satisfy the first condition, that it has a specified direction along with the magnitude, it obeys parallelogram law of vector addition, and the sum of the vectors should be commutative. Now, there is a question in your mind. Obviously there is a question arises in your mind. Is if a physical quantity is a vector, it has direction. As we had studied, if a physical quantity is a vector, it must has direction. But is its converse is true? Means if a physical quantity has direction, then can it be supposed as vector? May not. Why? May not. Why? Because first is time. What do you say about time? The flow of time is from past, present, and then future. Past, present, and then future. It has a specified direction, but it can't be treated as can't be treated as vector because it is not unique. For someone, time The past may be present, present may be past, it can't be decided. Second one is current. Current has a specified direction from higher potential to lower potential. Current has direction higher potential to lower potential. Always current flows from higher potential to lower potential. But it is a scalar quantity, not a vector quantity, because first thing is that it does not obey parallelogram law of vector addition. It obeys the law of general algebra, so it is not a vector quantity. And second, that the higher potential value and lower potential value is not specified for each and every case same, means it is not unique, so it is not a vector quantity. Some physical quantities, example of vectors are velocity. Velocity has magnitude as well as direction. Force, weight, momentum, impulse, torque, electric field, temperature gradient, these are magnitude and direction, so they are physical quantities, so they are vector quantities. These quantities are vector quantities, these magnitude and direction, so they can, or all the three laws it can be followed by them, so these are vector quantities. But in physics, there are certain physical quantities which can be considered as vector in special cases. There are physical quantities in physics, there are certain physical quantities which can be treated as vectors. For example, area vector. Area, while studying physics in various derivations in class 12th, you will see that various cases we take area as a vector. Area, an element, area element is taken and area element is considered, and the direction of this vector is normal to that element, so it is considered as area vector. Second is dipole moment. Second one is dipole moment. Dipole moment. Dipole moment means there are two poles, positive and negative, and its direction is from negative to positive, so it is considered as vector due to their specific direction, specific direction, so they are considered as vectors. Now vectors are divided into two categories on the basis of initial and final point or on the basis of their rotation. On the basis of initial or final points or axis of rotation vectors can be classified as, first one is polar vectors, and second one is axial vectors. First one is polar vector and second one is axial vectors. So what are polar vector and what are axial vectors? We will discuss. Which type of vectors are called as polar vectors and which type of vectors are called as axial vector. The first one is polar vector. Polar vectors means those vectors having one starting point, or you can say initial point, or point of application, one starting point or point of application. Two examples I am taking. The starting point and final point. Such as displacement. So these vectors are called as scalar vectors. Second one is, suppose you are applying a force on a wheel. At angle theta. If you are applying a force on a wheel, there is a point of application. Means those vectors are called polar vectors having any point of application, means at a single point you can apply that vector, or which have one initial point or a starting point and final point, that are called as polar vectors. And now axial vectors. Simple. Axial vectors are those vectors having axis of rotation. Second one is axial vectors. These represents rotational effect rotational effects and always along the axis of rotation in accordance with right hand screw rule. On the basis of right hand screw rule, this is your right hand, and if this is the axis of rotation, then direction of vector is along the direction of thumb, and if the axis of rotation is along this direction, then the direction of vector is in the downward direction. So this is the axial vectors. These are the axial vectors. I am drawing the diagram. Let us understand by the diagram also. This is anti-clockwise. This is anti-clockwise. Direction is anti-clockwise, so this is the direction of vector. And if look at here, it is the direction of the clock. It is opposite to the direction of the clock, so it is anti-clockwise. Note it down and understand it, because in physics it is always used anti-clockwise and clockwise direction. When the rotation is opposite to the direction of the clock, then it is called anti-clockwise, and if it is in the direction of the clock, then it is clockwise. This is anti-clockwise. Now look, this is clockwise direction. This is clockwise. This is clockwise direction, and this is the vector. This is the direction of the vector. So this is called as axial vectors. Now, one thing is worth noting, that vectors has their own algebra. Vector algebra is another thing, and it is quite different from ordinary algebra. Vectors have their own algebra, which is different from ordinary algebra, As you know that in ordinary algebra, 3 plus 4 is equal to 7, or A cross B is equal to B cross A. But in vector algebra, 3 plus 4 is equal to 1 to 7, because we use here parallelogram law of vector addition. and any of the number, the sum is any of the number from in between 1 to 7. And second thing is that a vector A cross vector B is not equal to vector B cross vector A. So dear students, this is all about for today, and there is a request to you or a pursuit to you that you must watch the whole video. Each and every student should have to watch the videos uploaded by the teachers throughout till and up to last to clarify your concept. Otherwise, you are not going to understand the concept. We are doing our hardship made to enhance your concepts, and if you are not utilizing it, then all these things are going in vain. So students, mind it and work hard, positively, honestly, to build up your career, because this disastrous situation is throughout the whole world, and the whole world is facing the same scenario, but study is also necessary. So that's all for today, students. Thank you. Have a nice day. Thank you, students.